In this video, we will finish stating the spanning set theorem. Remember the setting we're in. Share this. We are looking at non-trivial vector spaces with finite spanning sets. So part 2 of the spanning set theorem says that if this spanning set is not a basis, it can be turned into a basis by removing appropriately selected vectors. To see how this works, let's give, I'll call it a proof, although since I'm looking at a specific number of vectors here, it's more of an informal argument. Suppose we have this set of vectors spanning V. Then either they're a basis or they're not a basis. Why would they not be a basis? Well, bearing in mind that they certainly span V, the only way they could not be a basis is if they're linearly dependent. If they are linearly dependent, at least one of these vectors is a linear combination of the rest. That's a theorem that we have. Say, for example, that V sub 4 is a linear combination of the others. Then according to the first part of the spanning set theorem, we can get rid of it, and it doesn't change the span, so these vectors still span V. Now, either these vectors are a basis or they're not. If they're a basis, good. We have taken this set and turned it into a basis by removing a selected vector, just like we were trying to do. If they're not, why not? Now they still span V, so once again, the only reason this would not be a basis is if it's linearly dependent. If it's linearly dependent, one of these vectors is a linear combination of the other vectors. Maybe this vector, for example. And part one of the spanning set theorem says we can get rid of it, and it won't change the span. So we have three vectors. Either this is a basis or it isn't. If it's a basis, good. We've accomplished what we want to accomplish. If it's not, we are once again going to be able to throw a vector out without changing the span. Either these are a basis or they're not. If they're a basis, good, we're done. If they're not, one of them is a linear combination of the other, and we can get rid of it. And now this is definitely a basis. This set cannot be dependent unless this vector is the zero vector. But if V is the span of the zero vector, then V is trivial. And we've made the assumption that V is non-trivial. And that's the argument.